Hello there. Today I'm assembling a steam engine from a kit. We'll take a close look at the parts, the finish and the overall build quality as I put it together, and once it's assembled we'll see how well it runs. There are a few things I'm particularly interested in along the way, including the Govenor, the quality of the machined parts, and whether some of the brass looking components are actually solid brass or simply plated. Let's take a look. Before getting into the parts, the box itself is worth a quick look. Normally I don't like keeping packages like this. Once something is built, the box usually gets thrown away, but this one is quite nicely designed, and if the completed engine will actually fit back inside it for storage, then I might actually keep it. Be interesting to see, we'll find out later. Here we have all the pieces out of the box laid out on the bench. As you can see, there's not a huge amount. Some of the components are already partly assembled, so it should be a fun little exercise. All the pieces seem in good condition, apart from this one which has some weird scratches on the inside. But I'm not sure that really matters because, like I said, I'm pretty sure that's the inside of the firebox. You won't see that. This looks to be brushed stainless steel. Yeah, a lot of these parts are finished with this slight brushed effect. I assume that's stainless steel and these won't go rusty. Stainless steel picks up fingerprints quite easily, which is why the brushed is a slightly better option than polished. This is the base of the engine. It's fairly thick metal, so it doesn't have much flex in it. Finished with a nice powder coat. Nothing sharp on it. It's obviously been deburred nicely. Very impressed with that. Quite light. Can assume that's made of aluminium. Again, looks like the finish on it is powder coated. A very tough and wear resistant finish. The beam and piston assembly and the motion come already assembled, and the Govenor is also already assembled. On to step one then. So what we're doing is putting these parts together here, which I have laid out there, and then this is going to become a little sub-platform which has the piston, has the cylinder in for the piston, the support for the beam, and it'll have the supports for the crankshaft, which will have the flywheel on it. So I'll throw those together. That went together really easily with the supplied tools. Next I have these parts laid out ready to complete step two. And step two is to mount the sub-platform onto the base using the standoffs and the long bolts with nuts, and along the way it will also incorporate the two bearing stands which will allow the crankshaft to sit in there with the flywheel at the end. I'll go ahead and get that done. That went together relatively easily, apart from I managed to drop one of the nuts somewhere, and it took me 4 or 5 business days to locate it again, and along the way I found 5 or 6 things that I gave up looking for last week and have already ordered new ones. Anyway, so step 3, let's grab the parts. This is the pre-assembled beam and the mechanism that joins it to the piston, which is hollow. Need to check that all this is done up securely but moves sufficiently easy. There's not much power in these engines, and any source of friction is going to prevent them from running their best, so it's worth checking that at this point. This is just going to sit on top of the post that we put in before, and the piston is going to slot into the cylinder, which will be sort of here. Now the finish on this is rather interesting. Yeah, it's kind of like almost like a speckly finish rather than a polished surface like these other parts. And I do wonder if these other parts are brass and this is something plated. So I just want to do a quick experiment just to see what that is, just out of curiosity really. So I've taken a file to this so that you don't have to. Underneath here there's a clear section where I filed away the texture, and it's the same brass-like material underneath. Which shows that this texture is a design decision, which is attention to detail, which I quite like. And just to prove it's the same thing, I've taken the file to this bit of brass here, so you can see it's the same result. So essentially they are the same material, and I think this is some kind of brass. So yeah, let's solve that curiosity. Now I'm going to put it back together again and mount it there where it belongs. Well, this part's very simple to fit. Simply slots on the top, and this grub screw gets done up tightly to lock it in place once everything's aligned. So I spent way too long playing with this, because that's just fun. So I better get on to step 4, throwing in the bearings into the crankshaft support. They just seem to push in, just like that. Uh-oh. So simple, you can do that one-handed. Step 5. This being adding in the crankshaft and valve timing rod, which looks a bit like this. A nice brushed stainless steel finish again. Quite a thin rod. And it's got a bearing in there. That's the third bearing. Obviously we've got the 2 either side there. On the older steam engines, like the Mowards, I've got one sitting there in pieces, mid-restoration. There were no bearings, it was all bushes, just steel running against probably bronze or phosphor bronze with just a film of oil. But like I said, these don't have much power, these engines, and you essentially need to save friction wherever you can. So using bearings is a really nice addition, because these are pretty much maintenance free. A drop of oil will last on them a long time, so you don't have to oil these that often, and over oiling them actually adds too much friction. It just needs a very light coating, and these will be low friction and help the model run smoothly, so that's a nice touch. So I'll get that put into place. So step 6 starts to tie all this together with this axle that goes through the flywheel. It goes through the bearings, and then it's locked in place with a grub screw down onto the shaft. The shaft has flats on it, so the flywheel will grip onto the middle flat with the grub screw, and either end will have something, probably the crankshaft valve mechanism, and the other end, I think it's probably just a pulley to drive something, but we'll see as we go forwards. Step 7 is attaching the crankshaft onto the axle along with the little pulley, securing all down with a grub screw on the flats of the shaft, and not forgetting this tiny little spacer, which in comparison to my finger is about that size. These are the parts I'm about to put on. You can see me losing that 3 or 4 times before it's securely in place, and the pulley's just going to go here, and the crankshaft's already in place there. I just need to put the grub screw in. Let's get that done. One of the hardest tasks when machining up parts for a steam engine is to make the flywheel concentric. I've attempted it many times myself. Some turn out okay, others not so well. Let's have a little look how well they did here. I'll just place this tool very close to the flywheel, so as I spin this we'll see how close the gap is, whether it gets smaller and larger as it rotates. It's going to look worse on camera because I'm zoomed in, but you can see there is a wobble there, but overall it isn't too bad. I've certainly done worse myself. It does spin very freely at this point. At the moment it's just the flywheel in the bearings with the valve moving in and out. On to step 8 then. This is where we finally fit the connecting rod between the crankshaft and the beam, therefore completing the motion with a counterclockwise screw. That should be fun. So let's have a look at the parts. Yeah, I really like the shape there. Interesting design, nicely made. I believe that is 2 parts pinned together. I can see a little pin there. So that's made in 2 parts and then pinned together. That's probably how I would have made it. And the grub screw which holds this in is the smallest part of the kit. It's going to be fiddly, but that's going to be fun, and it has to line up with the flat on the shaft there when it gets inserted through to join it all together with the pivot point. I dropped that grub screw more times than I'm going to admit on camera, but that's the beauty of editing. Let's give it a spin. Yeah, that's very free moving, beautiful. The Runout is essentially a miniature version of the rotative beam engines developed by James Watt's designs in the late 18th century. Although it isn't a replica of any one particular engine, it's single acting with steam driving the piston in one direction, while momentum stored in the flywheel carries the mechanism through the return stroke. Its crank and flywheel arrangement reflects the development of beam engines for producing continuous rotary power, while a simple eccentric driven slide valve controls the steam. So it's time to fit the governor, which is driven off the pulley we fitted earlier onto this drive here, which turns 90 degrees through these nice bevel gears to turn the weighted balls at the top. Now this is actually a working governor, which they usually don't work very well on small engines, so I'm intrigued to see how well this is going to work. But as it spins, the ball moves out, which pushes this plunger down, and this plunger cuts off the steam which runs through this channel out there. So as I spin this, you'll see that plunger here move down to cut the supply off. And at the bottom there appears to be this adjuster which seems to put more tension on this spring, therefore meaning that the balls have to rotate faster in order to push this down. Which means that the engine would run faster before the plunger cuts the air off, meaning when it balances out, it'll be driving at a larger speed. So when we run it up, we'll have a play with that and see how much difference it actually makes to the running speed of the engine. For now, I'll get this mounted on, and then we'll move on to the next step. We've got these parts lined up here. This is going to make the firebox. It looks like you start with one side and then progress to put the other side and the end caps on, ready to support the boiler. I'm just going to go ahead and do it all in one step. Last part then, looks like we're just strapping the boiler on and plumbing it into the governor. Nice shiny boiler. It's got a whistle, a safety valve, which is the important bit, a tap to control the speed, nice little sight glass so you can see the water level. You can actually see a stay in there running right through the middle, end to end, which is a nice addition. Not seen that before in a small engine like this. Any steps after this? Right, looks like we'll be on to firing her up. if you're interested in buying one of these kits, then I'll leave the link in the description to the Stirling Kit website and this product, and in the description also is a discount code that you can use to get some money off. Check out some of their other products as well. They've got quite a wide range of interesting stuff on there. While waiting for that to raise pressure, I've got some updates for the sticker board. A plaque from Copthorne Vintage Weekend for displaying my engine there. A sticker from Modelling Mark and a sticker from Rusty Inventions. I'll leave a link to these two channels in the description. Thanks for sending those over. That's a nice addition to the sticker wall. Perhaps go and check out their latest video and see what you think. So the steam that comes out of the pipe into the engine, into the cylinders, obviously very hot because it's steam, and this piece of metal is cold, so instantly all of the a lot of the water vapour is going to condense. So there's a little drain here that we have to open to begin with, and just open and let some steam through, and we'll just let that drain of water. Not sure which way this is meant to go. Yeah, there's plenty of water just coming out of the bottom there. Yeah, these always run. They're very simple machines. Yeah, now that the water's stopped coming out, I'm going to shut this valve. And you can instantly hear the difference. Let's see how well the Govenor works. Yeah, it definitely makes a difference with the speed. And for those wondering if it fits in the original box, not really. Thanks for watching.